Alright, I've got another video that I'm going to have up here pretty soon, kind of going over exactly how I've made this, but this is going to be my attempt to add a brake to the i2000 with the Big Blue inverter. We got the Big Blue inverter to where it's working the way it's supposed to, but the dump load is constantly shorted out, so we can't. It doesn't regulate anything. It doesn't even let the turbine start up. So I put this together to act as that brake, and we have no wind right now, so I don't have anything that I can really demonstrate it with. But we're going to talk a little bit about what's happening here. So everything is fed in from the same, outlets that I've been using. I've got a really heavy piece of cord tying it together. It goes into this contactor. Ta-da! Into a three-phase bridge rectifier, same rectifiers that I'm using over here. And these are hot water elements. Now, if you find a single hot water element that will, work with your stuff, it's going to have to be submerged. And I very well might end up having to have these submerged. I'm kind of hoping for the best, or I'm going to have to run with a different kind of element. These are all 120 volt 1500 watt elements, which should put it right around 9.5 ohms. They actually ohmed out just a little bit above that. Running the 4 in parallel, it brings my ohm rating down to about 3.5, which is, I'm really not sure what the appropriate ohm rating should be for this turbine. I know that the resistor that came with this thing was rated at like 10, and I tried a 2 ohm resistor with it, and it just kind of shorted it out altogether. So I'm hoping that this will be somewhat in a middle ground. I will either be able to remove a resistor if I need to go down or up in resistance, or I've got a couple more of these elements if I need to go down. These elements should only draw 300 to 500 watts a piece. Might keep it, cool enough to operate up there. If not, we'll come up with something else. I think it'll be fine. Controlling it with this. Now, I know, I like these A30, not this one, obviously. I don't have a whole one in here. Oh, well. I like these A30 controllers because they do what I want them to do, but their downside is I can only get them out of China. The alternative is I can buy them from Missouri Wind and Solar or Hurricane for $30, $40, sometimes more, whereas it's a $12 controller, so that's what it should cost. What I've done instead is I am running this battery controller. It is a little bit different, but it uses the same relay. I have to modify it to work here, but and I'll have another video going over exactly how I've done that. The way this normally works, the negative is shared and goes across the top contacts. It hits high voltage, closes the relay, and you get, or opens the relay at high voltage, closes it at low voltage, or something like that. Yes. Closes at high voltage, opens up at low voltage. Okay. Closes at high voltage, opens at low voltage. I've got this altered to where the cycling circuit is no longer connected to the controller. It goes down to this 24 volt transformer, and then this 24 volt transformer operates this relay. Whenever voltage gets high, this thing is going to trigger close the relay. Yeah, and then close the other relay. Sends power to all of our resistors. One thing that I have done is that, because I want, like, our capped out voltage is going to be about 75 volts. This thing will start having problems right around the 60 volt area. Above that, and it starts getting finicky. At 80 volts, it just shorts. I've already tested it and tried it. It's not as resilient as this. So what I've got is a voltage divider that I put on the back side of this. I got a little terminal block on the back side and a couple of resistors to bring the voltage down to about 40% of what the input voltage is. Now I've got the input voltage going down to the dump load on this thing. So whenever the turbine gets up to about 50 volts, this is going to show roughly 23 volts. I think, if I did that math right. I kind of have to, see what actually happens. But this will let this controller get up to, about 75 volts and still load the turbine down without burning up my controller. So hopefully sometime in the next couple of days, we'll have enough wind to where I can actually try it out. So that's that. And thanks for watching, guys. Have a wonderful day.